So this is similar to a presentation that I gave in India when I was there in April with many of you that are on the call right now. However, there's a few updates, and I've tried to go into a little bit more detail because we have more time allotted for this call. So NSF International, we are an independent, not-for-profit, non-governmental public health and safety organization. Our mission is to protect and improve human health. As such, NSF has a large presence in standards development, testing, and certification for products that range from food equipment to water treatment devices, plumbing components, building water systems. We do a lot of auditing. There is some consulting that goes on at NSF, not in this program necessarily. And then our Biosafety Cabinet program, which is one of the smaller programs at NSF International, but also one of the longest and most established. So we've been around for a while. The photo on the left is our headquarters in Michigan in the US, but we have offices throughout the world, and I'll get into that in just a moment. Here's a summary of our services. Like I mentioned, food safety, consumer products, health sciences, water quality. NSF International is also a collaborating center for the World Health Organization in the areas of food safety, water quality, and indoor air. And I would love it someday if we could be a collaborating center for biosafety as well. But we're working on that, or at least I keep suggesting that. And I think somebody might take me up on it someday, so we shall see. This is a photo of one of our testing laboratories. This one is for drinking water treatment units, and it's pretty complex. That's a really neat laboratory. Our Biosafety Cabinet lab is not quite as exciting because the tests are done on the individual cabinets. We don't hook them up to big rigs or anything, but we're using individual pieces of test equipment to evaluate them. But we do have more than 2,000 employees. We do employ a number of microbiologists, toxicologists, chemists, engineers, and public health experts. And we have laboratories throughout the world. Unfortunately, our Peru laboratory burned down last year, so I should update my slide to reflect that. And then our India laboratory is brand new. Currently, we host a lot of IT professionals at our India facility, but we've recently renewed our lease with our landlord and expanded our capacities there so that we are going to be testing biosafety cabinets, the field certifiers in particular, and drinking water treatment systems or components there as well. So the goals for this webinar, and I think that they were in the invite, are to give an overview of biosafety cabinets and how they function. And I hope it's not too rudimentary for the people that are sitting in on this call, because I feel like I might be preaching to the choir in that you all are experts in this field. But hopefully it can give you a tool later on. You can take this presentation and share it with others that might want to learn more about this program and about biosafety cabinets in particular. So we'll look at some of the issues that are related to choosing what technology to work in, how to use it and maintain it. We'll talk about some of the field tests that are required to ensure that the cabinets are functioning as intended over time. And then we'll also look at the tests that NSF does at our headquarters on a qualification job. So when a manufacturer comes up with a new model that they want to have tested and certified, what is it that NSF does at its engineering lab versus what's done in the field after it's installed? what should you do if your cabinet is out of specification? And we'll talk about some of the other international standards and let you know about our training and testing centers in India. So just for a quick overview of the different BSL levels, and I know, again, I'm speaking to people who know more about this than I do, so feel free to correct me if I'm wrong on anything. But there's 4 different biosafety levels that they do with the risk assessment for work being performed in a particular laboratory. And one thing to keep in mind is that biosafety levels 1 through 4 are not necessarily equivalent to the risk groups for individual organisms. Now, in the US, we work off the BMBL quite a bit, and that stands for Biosafety in Microbiological and Biomedical Laboratories. It's a document that is maintained by CDC and NIH. Here in the US, it's similar to the World Health Organization's Laboratory Biosafety Manual, which I believe is currently being updated and should be finalized very, very shortly. So when you look at a risk group, those are based on an agent's ability to infect and cause disease in a susceptible human or animal host. It's also based on an agent's virulence, as measured by the severity of the disease, whether there are any preventative measures and effective treatments for the disease, such as whether there's immunizations that are available, and the route of transmission. So that's talking about risk groups for individual organisms. When you're thinking about biosafety levels, you're also taking into account what type of facility you're working in, whether it's an animal facility or clinical one, what the work is that's being performed, whether you're dealing with increased volumes or concentrations of infectious agents, and if so, do those require additional containment practices? So here's a summary of BSL Level 1. So BSL 1 laboratories are suitable for work that involves well-characterized agents that are not known to consistently cause disease in immunocompromised adult humans, or competents, and they present minimal potential hazard to laboratory personnel and the environment. BSL Level 2 and 3 labs are where you're most likely to see the biosafety cabinets that we're going to be talking about today. Biosafety Level 2 laboratories, they build upon the BSL Level 1, and they are suitable for work that involves agents that pose moderate hazards to personnel and the environment. The differences between BSL Level 1 and BSL Level 2 are that laboratory personnel have specific training in handling pathogenic agents and are supervised by scientists that are competent in handling infectious agents and associated procedures. Access to the laboratory is restricted when work is conducted, and all procedures in which infectious aerosols or splashes may be created are conducted in BSCs or other physical containment equipment. For BSL Level 3 labs, they are applicable to clinical, diagnostic, teaching, research, or production facilities where work is performed with agents that may cause serious or potentially lethal disease through inhalation. Laboratory personnel must receive specific training in handling pathogenic and potentially lethal agents and must be supervised by scientists who are competent in handling infectious agents and associated procedures. And then finally, BSL Level 4 labs, where biosafety cabinets may still be used in BSL Level 4 labs, but they would be in conjunction with positive pressure suits. So that would be called a suit laboratory. So BSL Level 4 is required for work with agents that pose a high individual risk of life-threatening disease, aerosol transmission, or a related agent with unknown risk of transmission. Agents with a close or identical antigenic relationship to agents requiring BSL level 4 containment must be handled at this level until sufficient data are obtained, either to confirm continued work at this level or to redesignate the level. And again, laboratory training is critical, and documentation of that training is also critical as well. So let's see. This slide was given to me by one of my employees, and sometimes it plays a little fan that shows the way the air is being pulled through the unit. I'm not sure if that's showing up on your end or not. But regardless, it's a good graphic. I really like it. And so this is showing a Class 1 BSC, and you can see that it's pulling air into the unit so that it's providing protection to the laboratory worker from any pathogens that are present in that work area. So there's a minimum velocity for the inward air of 0.38 meters per second, and that air is HEPA filtered prior to being exhausted. However, if you're doing delicate work within that work area, there is the chance for contamination from the room air. So if the laboratory worker is sick with something and is coughing or sneezing, or even just dust particulates and airborne contaminants that are naturally present in the room. So Class 1 BSC will provide that personnel protection, but it doesn't provide product protection. And this is the inverse of what would be called a clean bench, which provides HEPA filtered air down onto the work surface, but doesn't necessarily protect the user from any danger that might be present. Class 2 BSCs, these are the types A1, A2, B1, B2 that are defined in NSF Standard 49. There's actually a fifth type called a C1, but only one manufacturer produces that at this point in time. So I didn't include it in the presentation, but I did want to mention that there is this additional designation for biosafety cabinets if you run across that in the field. So biosafety cabinets are primary containment devices. They're critical to laboratory safety. They rely on the movement of air to provide personnel, environmental, and product protection. And in doing so, they require a very delicate air balance between the inward air and the downward air in the work area. There's also protection from side-to-side cross-contamination of products, and that is ensured by the laminarity of the airflow, making sure that the downward air is very similar at different points throughout the work area. And again, environmental protection is provided by exhausting the air through a HEPA or ULPA filter. You can recirculate the exhaust air in the laboratory, or you can exhaust it remotely. Whenever people ask if a Type B cabinet is safer than a Type A, NSF will informally recommend a Type A because if you are exhausting a Type A through a canopy connection to remove odors from the work area, and that external exhaust breaks down, that biosafety cabinet, while it might allow the laboratory to become smelly with whatever odors are in the work area, it's providing biological containment still. So there's an additional level of assurance with Type A cabinets that they are providing biosafety even when they're not properly functioning, or the exhaust system is not functioning properly. With a Type B cabinet, it relies on that external exhaust system to function. And in that case, you want to make sure that it's exceedingly well maintained and checked very frequently to make sure that the exhaust blower is functioning as intended. So I talked about Class 1 and Class 2 BSCs. Class 2 is what we deal with our NSF Standard 49, and they make up the bulk of the marketplace. There are also Class 3 biosafety cabinets. I did not include a slide for these because they're used in the biosafety level 4 labs primarily, and they aren't so generic that I could come up with a good representation of one. There's a lot of different variations that can be used with glove boxes, but they are the highest level of containment for biological agents. They're totally enclosed with double HEPA filtration on the exhaust. And if you want more information about those, you can look at the BMBL or the Laboratory Biosafety Manual from the World Health Organization. So ever since I've been with NSF, I've been hearing from customers and regulatory officials that biosafety cabinets are great. They work well if they're maintained properly. But worldwide, and this includes the United States, there's a lack of understanding of how biosafety cabinets work. Some people may think that there's only one safe downflow velocity in the cabinet, or it might be an assumption that air flows into the unit but doesn't come out again. So there needs to be more awareness and more education about how biosafety cabinets function and why it's important to ensure that they are functioning properly over time. So sometimes we've done site visits of various laboratories where they've been using clean benches for work where personnel protection is required. And the reason why a clean bench would not be a good choice in those types of scenarios is because the air is coming right out through the front opening. So you get a nice, clean, HEPA-filtered air within the work area, but no guaranteed protection of the laboratory worker. Without trained professionals in countries that are under-resourced, even the best constructed biosafety cabinets will eventually become liabilities if nobody is present to verify their airflows, check on their HEPA filters, and rebalance and maintain them if necessary. In addition, field certifiers need access to calibration laboratories for their test equipment. We know from communications with individuals around the world that it's very difficult to find quality laboratories to calibrate the test equipment that are also local. So what some people are forced to do is ship their equipment overseas for calibration and then hope that it comes back intact without being inspected by customs and damaged in the process. This is a very costly experience as well, shipping things overseas and using higher cost laboratories. So one component that we haven't quite solved, but certainly it's on everybody's mind of biosafety, is ensuring that there are calibration labs that are locally available to maintain field certifiers' test equipment. And I'll come back to that in a little bit. So this is a photo of a clean bench. It's not a biosafety cabinet, but it illustrates quite nicely what we have seen in some laboratories where we were not allowed to take photos, where people are storing boxes or other items on top of cabinets. And if there was a box on top of an exhaust HEPA filter, then it would compromise the ability of that cabinet to provide containment. So in blocking the exhaust, it could cause some air to escape out through the front window of the cabinet, and it would certainly change the airflow balance of the unit. Some people don't take traffic into consideration when they are designing laboratories. And when you walk by a biosafety cabinet particularly fast, or if you're moving your arms fast inside the work area, you create air currents just as you would within a swimming pool if you're swimming. And that could draw contamination in from the room into your laboratory or your work area, or it could pull contamination out of the cabinet and therefore exposing the laboratory worker to the potential for infection. So it's important to place biosafety cabinets in areas that aren't subject to a lot of airflow, so not in main corridors, not near open windows, air conditioning vents. Trying to think of some other scenarios. If you have too many people working inside one unit, say if this unit in the picture had 2 people working side by side, their arm movements could disrupt the airflow within the work area. Their arms could also block the intake grill for the biosafety cabinet. So these are all considerations to put in place when you're designing a lab and also when you're inspecting a lab to make sure that you're providing the safest environment for your workers. Maintenance issues, I talked earlier about the equipment that is required to certify biosafety cabinets. So when a laboratory is planning its annual expenditures, they should put aside some budget for an annual field certification of every biosafety cabinet in the lab. For those who are performing the field certifications, they also need to think about budgeting for equipment calibrations to ensure that their equipment is giving them the best readings over time. And there's a lot of bad field certifiers out there too. So I have some photos further on in the presentation of people who sort of know what they're doing, but have a ways to go. So if a laboratory manager wants to make sure that the people testing their biosafety cabinets are qualified, we do provide some resources, some videos showing the test methods as they should be performed. And then if they want to pop in and spot check a field certifier while they're testing equipment in their lab, they can say, oh, this looks like the video that I saw, it looks like they're doing it correctly, or, oh wow, this guy's not using a ring stand to hold his probe, he doesn't seem very professional. So we do have links to those later on in the presentation. So on the right is a worker who is using a fixed ring stand to hold her anemometer in place while she's taking airflow readings. She is getting the most accurate data by using that fixture, whereas the gentleman on the left is just using his hand, and he's going to get some varying results with his downflow readings. So if I were a laboratory manager and saw somebody taking airflow measurements with their hand, the official measurements, that would concern me, and I would have a word with them. Now, you could use your handheld probe to get a feeling for what the airflow is within different regions of the cabinet, if that's for unofficial purposes. So it's not necessarily a red flag all the time, but if they're taking their actual measurements for a field certification and they're using their hands, then that is a red flag at that point. Here's a biosafety cabinet. It's a good cabinet. It's NSF certified, so we validated that it performs properly, but it went into a laboratory that had very low ceilings. So this is a photo that was given to us by some field certifiers who were asked to check this facility. And they asked, how are workers supposed to work in this cabinet because it's maybe 2 feet off the ground? And they were told that the laboratorians were asked to sit on furniture dollies while working in the biosafety cabinet. And if they needed to get from one cabinet to the other or to get supplies from across the room, they could just scoot on those dollies. So there is some really crazy stuff out there, and it's not going to keep their clean environment clean for long with their hands dragging on the floors like that. And then I did have a video in this presentation earlier, but I couldn't figure out how to blur the manufacturer's name. So I'll just describe it to you. There's a biosafety cabinet manufacturer that has a video on YouTube of their product, and as they're demonstrating it, they're turning the UV light on and off, they're turning the regular lights on and off, but the window is open the entire time. So it's important to use standards when purchasing cabinets, not only when field certifying them, because all of the major international standards for biosafety cabinets say that there has to be an interlock with the UV light, so that if you open that sash, that front sash, it automatically goes off and prevents workers from being exposed to that UV light. Here's another photo that was given to us by some field certifiers in the program, and it shows a cabinet that had been in use for several years, and it had a couple stickers on it saying that it had been certified. But when they took the diffuser off to look at the supply HEPA filter, there were obvious gross tears in it, and it looked like they had been there for a long time. So I guess it's possible that that filter was torn after the prior field certification, but my gut instinct tells me that whoever did the field certification prior to this one didn't check that closely when they were scanning the HEPA filters, and therefore missed what would surely be a large leak. And finally, this is a direct connected Type B to biosafety cabinet. We're looking at the top of it, and the ductwork is connecting it to the exhaust system. And they couldn't figure out why the cabinet was so difficult to balance. And it's because this transition on top of the cabinet had collapsed upon itself and blocked a significant portion of the exhaust air. So field certification of biosafety cabinets is critical. It is recommended every year by both the BMBL and in NSF 49, which is the standard developed by NSF. Okay. Oops. So this is an excerpt from an article that was published in Applied Biosafety in September 2016. It was a really great study that was conducted by some individuals from Thailand, really smart people. They tracked the training and accreditation of individuals that they sent through the traditional training experience for field certifiers. And they determined that it cost about $60,000 per person to get one individual trained and accredited to test biosafety cabinets. And that's because there aren't many training opportunities worldwide. There is a training center in Maine in the United States that is a not-for-profit organization affiliated with the Baker Company that makes biosafety cabinets. There's one in Texas in the United States, one in Canada, and I think there's another new one in California. TÜV Nord in Germany has a training program for field certifiers. And then there's some other local ones. Asia Pacific Biosafety Association is doing some really great work with training recently. But the newer regional ones weren't as prominent when this article was written. And they were trying to get people trained by sending them to Maine in the U.S. for a week-long training course, bringing them back home again to get a year's worth of experience, which was required for NSF accreditation at that point in time. And then they would ship them back to the United States a year later to take the accreditation exams. And that was great. Those people got amazing training opportunities. They had a wealth of knowledge. What happened quite often is that after a company had spent that much money to train and accredit somebody, they left for a higher paying position with another company. So it's very frustrating for their employers. And then also they did a survey, the individuals that wrote this article, and it showed that more than 30% of Class 2 biosafety cabinets were poorly designed, incorrectly installed, not certified, or not operated correctly. And then more than 40% of all BSCs are sold into countries that have no routine field certification. So this article, when I read it, was a bit of an eye-opener. Of course, we knew that there were problems globally from what we had heard in the past, but actually seeing the dollar amount that was associated with training people to become field certifiers, that was an eye-opener, and made us think that perhaps we could come up with a program that would be more innovative and cost-effective. So for a little bit of background on NSF and our program, we established the program in the 1970s. I was not here at the time. I was born in 1971. So unbeknownst to me at the time, the National Institutes of Health, CDC, and the National Cancer Institute had a bid specification for biosafety cabinets that were used in their laboratories. And that bid specification was shared with other laboratories throughout the United States, and it became an informal standard for how biosafety cabinets should be designed. That was given to NSF. We are a standards development organization in addition to testing and certifying products. And so they requested that we turn it into an American national standard by going through a very specific process where we work with different stakeholders to ask what they want to see in the standard and what they deem to be critical parts. And so we were happy to take that on. It was a really exciting project, and NSF does not develop standards in a vacuum. We do assemble a group of stakeholders that are representative of the public health or regulatory community, manufacturers, and users of cabinets. This slide is one of the breakout sessions from our last joint committee meeting. We're trying to brainstorm. I'm trying to read the slide. I think it says acceptance criteria for Annex E. But there's a joint committee. It's about 20 people that meet annually at our NSF headquarters. It's a completely open process, so if any of you would like to attend or give us your feedback, write in with issues that you'd like to see the joint committee address. We are most receptive to that. The Joint Committee will also work on individual technical topics throughout the year, and those are done via conference call and emails. But this once-a-year meeting in Ann Arbor headquarters is usually pretty exciting because we talk about the standard and where its shortfalls are and where it can be improved. So it's a really dynamic document that is continuously updated to reflect new technologies. So when we took the bid specification on from NIH and CDC, they asked us to develop a national standard. We did that. They asked us to develop a certification program for biosafety cabinets, and that's where the manufacturers themselves, the Bakers, Lab Concos, ESCO, New Air, Thermo Fisher Scientific, those are our customers, and they send us products to test and evaluate. That was the second component of the program. And then in 1993 is when we started accrediting individual people to do the field certifications on units that are installed in laboratories and hospitals to verify that they're functioning properly. So a quick overview of what certification testing is. We test biosafety cabinets both at their recommended airflow settings. So some manufacturers like Baker have very low downflow readings. They like their cabinet to be really quiet, so they kind of push the boundaries on the downflow velocity. Whereas if a manufacturer like Lab Conco is selling to Australia, and Australia has a minimum downflow level, that's a higher one than what's required in the US. So we'll test with whatever downflow velocity the manufacturer would like to have the cabinet tested to. However, once we set those cabinets at their nominal settings and they pass all of the tests in the standard, we then set them to out of balance conditions. So we might increase the inflow velocity and decrease the downflow velocity and see if there's the potential for pathogens to make it into the work area. And conversely, we could increase the downflow and decrease the inflow and see if there's any escape of pathogens from the work area into the laboratory environment, therefore potentially infecting laboratory workers. So in that first bullet point where we are testing at both nominal airflow settings and out of balance conditions, those are pretty rigorous tests. The setup in the photo is our personnel protection test. And you can see that there's a bunch of different apparatus that are designed to see if any pathogens get out of the cabinet. So there's a nebulizer, which is that little bottle behind the glass, and that has Bacillus subtilis in it, a certain challenge concentration. And there's compressed air blowing through that so that it's coming out as a mist. It doesn't show up well in the photo. And then that mist should be entirely captured by the front intake grill. But if it's not, we can detect it using those impingers, the tubes that are, or the glass bottles that are hooked up to the tubes. They're breathing in, simulating human use. So the air is flowing in through those impingers at a certain rate, which I don't remember. And then there's also slit samplers to either side of that apparatus, and that's to see if any air escapes at a lower level. And you might wonder what that metal bar in the cabinet is. That is supposed to be simulating an individual's arm if they're working in the cabinet. So one thing that would be neat to see over the years is if we could design a movable arm to better simulate a laboratory worker. But anyway, we do those microbiological tests, inflow tests, downflow tests. We check the motor blower performance under strain, so that simulates as a HEPA filter becomes more blocked up and becomes more resistant to airflow. Does that impact the ability of the cabinet to stay within the airflow requirements for the standard? And there's also some structural integrity tests, and we check the alarms. So there's about, I think, maybe 15 to 18 different tests that are conducted at the NSF headquarters in order to certify a product. Now, field certification is a subset of those tests. And if you want to look into the nitty-gritty of the details, the field certification tests are described in Annex F of NSF Standard 49. But the purpose of field certification is to make sure that those airflow settings are still within the range that was validated by NSF International or another organization. So TÜV Nord will test biosafety cabinets to the EN standard. I forget the name of the French company that does certifications too, but Public Health England will test biosafety cabinets to their standards. And then there's also testing of biosafety cabinets in China. So whatever organization has validated that the biosafety cabinet works is you should use the same standard to make sure that the field certification is accurate. So we're tying back the results from the field certification to that initial certification by a third-party testing agency. So you want to make sure that the airflow settings are within range. And if you're wondering what that range might be, and there isn't a data plate available on the cabinet, you can always look at the NSF online listing to see what downflow velocity or inflow velocity should be used. And if it's an older model, there are ways to determine what the airflow settings were when the cabinet was certified, even if it is no longer a new model. And the recommendation for that would be to work with an organization called CETA, C-E-T-A, and they maintain historical airflow data for various models of cabinets. So you're also testing the HEPA filters annually at each field certification to make sure that they're not damaged or loaded to the point that they are affecting the airflow balance. You can visualize the airflow within the cabinet with various smoke tests, and these are required as part of that annual certification. And then there's also verification of alarms at that point in time. And one thing that we are working on in the program is having a decontamination test. And that's something that we've just rolled out in the other accreditation program, the enhanced accreditation program. And I think at some point we'll add it to the basic accreditation program as well, just to make sure that field certifiers understand the signage and PPE requirements when they're doing decontaminations. There's some other additional components that they would be asked to demonstrate. So we have two accreditation programs for field certifiers. One is the old North American model that was developed in 1993, and that's the one that was kind of criticized, very aptly so, in that Applied Biosafety article. So that model requires at least a high school diploma, 1 year of experience testing cabinets, which is difficult when many companies actually require that their field certifiers are accredited. It requires experience testing both Type A and Type B biosafety cabinets. And then there's a written exam. It's a 3-hour, 120-question exam, and a practical examination. Those field certifiers are also required to show NSF proof that their equipment is calibrated on an annual basis, and there is a signed ethics statement that has to be completed prior to listing them as NSF accredited. In 2017, in response to complaints from global customers that our program was too expensive for people from overseas and too time intensive and all in English, which is difficult obviously for people that don't speak English as a first language, we came up with a new model that is basic accreditation. So basic accreditation can be seen as a stepping stone to eventually being an enhanced accredited field certifier. But it really focuses in on Type A cabinets because those make up the bulk of biosafety cabinets worldwide. I think the percentage is somewhere between 75 and 80% of biosafety cabinets are Type A cabinets. So by focusing in on those and then also allowing for inflow testing to be done with an anemometer instead of a DIM instrument, which is somewhat expensive, we were able to reduce costs and reduce the number of tests required. We also wanted to focus on international standards and elevating the awareness of those. Of course, we're partial to NSF 49, but it's not the only standard out there. And the other ones are really good documents as well. And the importance is getting biosafety cabinets certified. So let me see what else I'm missing from here. In the U.S., because our traditional accreditation program had been around for 25 years, or slightly less than that, we don't have the option for a basic accreditation here in the U.S., but it is an option in other countries, particularly paying attention to those that are under-resourced, either financially or in terms of educational opportunities for this particular technology area. So the benefits of this program are that we can do training and testing in the native language if we're given enough time and money to prepare for that. So we can have translators available when it's necessary. There is a shorter written examination that is more math-based, and in cases where that needs to be translated, again, we have the willingness to do that. And the fact that the exam is shorter makes that an easier task. We donate personnel time, the cost of our NSF personnel, to go and spend a week or more in a different country to oversee the testing component of things. And that way, the people who are going through the training program don't have to travel back and forth to the U.S. They can stay in a local area that is more convenient to them, and they don't have to spend as much time away from home. So we've also, for the basic accreditation program, can do it in one opportunity. So a week or more of training would be the very minimum that we could do. We've partnered with other training organizations to have either 1 or 2 weeks of training in the past, after which NSF offers the accreditation exam. And like I mentioned earlier, there's fewer pieces of equipment that are required. So those are more portable, and because there's fewer pieces, it's more cost effective to get them, to purchase them in the first place and to keep them calibrated over time. To critics of the new program, and there were some at the beginning, whoops, I'm progressing too fast. For critics of the program, we would make the following arguments: that there's more similarity between the basic accreditation program and the enhanced one than there are differences. So both of them have minimum education requirements. In fact, the education levels of those who have come through the basic accreditation program thus far are significantly higher than what we see in the U.S. So I'm pretty much in awe of all of the students that have come through so far. There is training on biosafety cabinets. Both programs require that there be training. They both have written and practical examinations. They both require that NSF see proof on an annual basis of calibrations for the test equipment. There are ethics statements that must be signed. And then our basic accreditation program candidates also have to be aware of other international standards, whereas in the U.S., pretty much everyone uses the same one standard, NSF 49. So in many ways, the basic program is more rigorous than the enhanced program, even though it has a tighter scope. And then I have some fun photos of testing that we've done in the past. Our first test session, which we did a really awful job with, was in Thailand. The hosts were absolutely lovely. The candidates were lovely. But NSF, it was our first time testing people, and we didn't allocate enough time for people to get practice doing the various test methods, nor did we have enough time for them to all complete their practical exams. So that was a big learning curve for us. And here are the wonderful participants who took place in the program. Most of them are now accredited. Some of them even went through the enhanced program. And if you're looking for a training facility in Thailand, the Department of Medical Sciences has a phenomenal facility with biosafety cabinets that have never been used with pathogens. So and that's one thing I wanted to note in those earlier slides, is that you'll see us working without gloves on. And that's because we are working with training units that either have been decontaminated or were never used with any pathogens to begin with. That Thailand training session was conducted with support from the Government of Canada, the Thailand Department of Medical Sciences, Ministry of Public Health, and Walter Reed Armed Forces Research Institute for Medical Sciences in Nepal. Our second training and testing program that we conducted was at Singapore at Temasek Life Sciences on behalf of the Asia Pacific Biosafety Association. And that was a one-week-long training and testing workshop like the previous one, but this time we were a little bit better prepared. We had funding for that through the International Federation of Biosafety Associations, Global Affairs Canada, the Asia Pacific Biosafety Association itself, and that program had the additional component that in exchange for funding for training for the individuals, they had to produce country-specific biosafety plans within a couple of months after the training. And so I have not seen those. That's something that is managed by the International Federation of Biosafety Associations. But I thought that that was a really neat component of that workshop. And that workshop was also neat because it had additional funding consideration that was given to women who are engineers. In January of last year, we went to Porton Down, England, and tested individuals from Mongolia and Kazakhstan. And they had funding through an EU project called Project 53. And this was neat because the funding that they had was sufficient enough that they could spend 2 weeks in England. So they had the first week that was nothing but training, and then the second week was for testing. And with only 8 people to test over 5 full work days, it was a very nice atmosphere where we weren't quite so rushed, and that worked out nicely. And then I'm headed back there next month to test individuals from Nigeria and Zambia. And you might see some familiar faces in this slide. This was the workshop that took place in Noida in April 2019. I had the best food of my entire life while I was there, so thank you for that. This was supported by the World Health Organization, the Indian Association of Medical Microbiologists and Centers for Disease Control, and the host facility was the National Institute of Biologicals. We had a small test session in Ethiopia in September where 4 people were accredited, and that one was sponsored, I believe, by APHL, the Association of Public Health Laboratories. And I think somebody might not have us on mute. So if you're on your phone and don't mind hitting mute, please do. And finally, the last test session that was conducted was in Singapore, again with the Asia Pacific Biosafety Association at the same facility. So I'm wrapping it up soon, I promise. I know this is a long time, and thank you for your patience. Lessons learned. So we are human too here at NSF, and we've learned a few things by conducting these workshops. One is the more time, the better in all cases. So I think both India and Ethiopia, we had some fluctuations with the power supply. And if that is going to be a potential at other test sites, it's fine. We just need to build in extra time to accommodate for that. In some cases, the test facilities have secure access, and so we need to do better planning so that we coordinate with those personnel in advance to get us the time that we need to do the training and the testing. We need to allow some extra time for test setup. And I wasn't there at this session, but in Ethiopia, my coworker was pretty nervous for a short period of time. He's excellent and brilliant and figured it out. But at first, one of the biosafety cabinets was not functioning properly because it had been disassembled for training. So he was able to get that up and running properly and do the testing as planned. We can be more forthcoming with the requirements for the test equipment. We have developed a spreadsheet since our initial workshops that list where you can purchase equipment, what the approximate cost should be, and websites, phone numbers for doing that. And we're starting to compile a list of calibration centers globally that are available for maintaining that test equipment. Communication's always key. I'm not the best at it, so that is a learning curve as well. Internally, NSF has had some issues with invoicing, not invoicing too much, but just not invoicing at all, or having it delayed. And that has to do with our internal IT systems, which need to be updated. And I think the key priority for future workshops is to allow more time, and that's for the retests as well as dealing with facility and equipment issues. But the second most critical point that we've learned is that we really need to be better about letting people know that it's very, very common to not pass all of the tests the first time around. And it's not a bad thing. It's pretty normal. Here in the enhanced program as well, people have to do multiple test sessions to complete all of the practical exam tests. And I know that's harder when you're waiting for NSF to come in country to offer the workshop. But it's something that we can do a better job of planning for in the future. All right, 3 more slides to go. We do have a new facility in India that I alluded to earlier. This is new construction. They are installing the biosafety cabinets as we speak, and the test equipment has been purchased. Everything is brand new, which will be nice. We don't have to worry about decontaminating anything. The space is small, though, so we can probably only test between 8 to 12 people per workshop. But there's some seminar space for training, and we would propose at least a week of training, followed by the accreditation exams. And we are aiming to hold between 4 and 6 training and testing workshops at this facility each year, starting this year. And this is located in Gurugram, just south of Delhi. And I've not seen it yet, but I'm pretty excited. And as part of this effort, we are going to be offering training through NSF as well. Whereas in the past, we've relied on other external companies to provide the training component of things. This time around at our India facility, we will have one person dedicated to training and then a different person dedicated to the accreditation testing. And we'll keep those two parties separate so that there's no conflict of interest. And then finally, if you want to see the individual test methods in video form, you want to see how the downflow test should be run or how the inflow test should be run, whether you're a laboratory manager that wants to double check on the people coming into your facility, or you're a field certifier yourself and want to brush up on some test methods that you haven't used recently. We do have videos of inflow, downflow, HEPA filter testing, and the smoke tests, and they are available at the YouTube links that are on this slide.